Today we are going to learn multi-layer perception learning algorithm. What is it? It is a type of feed-forward neural network with multiple neurons in layers, and all neurons in a layer are fully connected to neurons in next layer. Input layer is visible layer. Activation layer can be linear or non-linear. Sigmoid activation function is used if the problem is binary classification, and soft maximum activation is used in multi-classification problem. We have to remember this activation function, sigmoid and binary classification, soft maximum activation. What are the inputs here? Input vectors are x1, x2 and so on up to xn. What is output? Output is denoted by yn. Learning rate is alpha. First step is forward propagation. In forward propagation, we will calculate input and output in input layer. Here input is equal to output, ij equal to xj. I is summation of I is equal to 1 to n oi wij plus x naught into theta j. And the other formula we use here is oj equal to 1 plus 1 by 1 plus e power minus ij. Estimated error at node in output layer. Estimated error is equal to if we want to know the error reduced, then it will be desired output minus estimated output. Step 2 is backward propagation. Output error k is equal to ok, what is output, into 1 minus output k into desired output minus ok. It is for hidden. For output layer, for hidden layer, the formula is error j is equal to oj into 1 minus oj summation of k error k w j k. Next we have to update weight. For update weight, learning rate is 0.8. It is denoted with alpha, and wij is equal to wij plus alpha into error j into oi. As you can see, this I here, wij is wij. Delta wij is equal to alpha into error j into output I. Here wij is calculated by wij plus del wij. This wij value from here is substituted in this. And next we have to update bias. How to update bias? Theta equal to theta I plus alpha into error j. Let us take an example. This is example of multi-layer perception learning algorithm. These are the inputs x1, x2, x3 and x4, and these are the hidden layers x2 and x6. x0 is here base and x7 is the output layer. These are the weights which are given here. Now we have represented this. These are the output and input for x1, x2, x3 and x4. This is output desired is 1. We have filled this table with these values from here. Now calculate input and output. As we have given here 1101, these are the input and outputs. Now input hidden. We have to find here a unit. What is our unit here is x5. So net input ij is equal to summation of like what are the inputs x1, x2, x3, x4 are the inputs, and these are the weights from 1 to that ij plus this is base into theta phi. Output j is calculated by using oj equal to 1 by 1 plus e power minus ij. Here we have substituted the values and got the result. Up to now we found values for input layer nodes. Now we are going to find about output layer nodes. What are output layer nodes? x7 and for x7 using the formula ij equal to summation of I equal to 1 to n oi wij plus x0 into theta j. We are substituting the values as we have got there. After substituting we will get our result. In the same way we have to do for O7. Now calculate error. Error is equal to desired output minus estimated output. As what is desired is 1 and estimated output is 0.419. This is the result which we get. If you are happy with error, then keep it. If no, then back propagate to reduce the error. This is a back propagation formula. For unit k in output layer, this is the formula. Error k equal to output k into 1 minus output k into desired output minus output k. And for hidden layer, it is error j equal to output j 1 minus output j summation k error k wjk. For output layers x7, we have found by using the formula. We have got the value. Now for hidden layers x6 and x5, we are using this second formula and got the values. Now we have to update weight using function. For this, learning rate is alpha equal to 0.8 and wij equal to wij plus alpha into error j into output I. The update weight and bias. This is wij equal to alpha into error j into oi. Here you will get new weight by substituting these values and doing calculation. In the same way, we have to find up to W67. This is update bias. For updating bias, we use this formula theta equal to theta I plus alpha into error j. Theta j equal to theta j plus alpha into error j. Okay, theta 5, theta 6, theta 7. For to find new bias, we will use the formula and after calculation we will get the value. Now we have to calculate input and output in hidden layer and output layer with the updated values. These are the same formula as we have used earlier, but here we are using updated values. This is for hidden layers x5, x6. So this is a summation x0 into theta j. Output is output j equal to 1 by e power minus 1 by e plus 1 by 1 plus e power minus ij. After calculating x5 value, we will find x7 value and x6 values. Now the error we have to find out. What is our last one we got? 0.7474. Error is calculated by 1 minus this value. Then we got the 0.526. What is reduced error here is? Reduced error is first result minus last. This error which we got here with new updated values. Then we will get the reduced error.